Hi everyone, this is your Unit 7 Lesson 3 video on slope fields. These notes are on page 14 of your packet, and we have one learning objective for today. It is estimate solutions to differential equations. So we've been working with solving differential equations. We can get a particular solution or we can get a general solution, but either way we've been solving them. We're going to look more at a visual way of estimating solutions when we're not actually able to solve or when we don't want to actually solve the differential equation. So we're going to do this using slope fields. A slope field is a graph that helps us visualize the family of solutions to a differential equation, even if we cannot find the general or particular solution using antiderivatives. One thing that we want to make sure we remember is that dy dx is the slope of a curve, or really the slope of the tangent line at a particular point. So sketching tangent lines at specific points gives us a picture of what the original curve looks like. It sounds really confusing, but once we do some examples, hopefully you will understand what we're talking about here. On the axis provided, sketch a graph of the slope field at the particular points indicated. So we want to consider the differential equation dy over dx equals x over y. Now we've worked with solving something like this before anyway, but we're going to look at more of this visual approach with the slope field. So to help us out with this, we're going to make a table, and you don't have to do this, but it kind of helps, especially in the beginning. It helps us to organize our thoughts and kind of make sure we do all of the points that they're asking and we know where these things are coming from. So we know dy dx is equal to x over y, and we need to create little tiny pieces of a line on each of the points that we see on the graph here. So I'm going to start all the way over on the left in quadrant 2. I'm going to start at the point -2, 2. So I'm starting with this point right here. If I plug that into my differential equation, I've got -2 over 2, which gives me a -1. What that tells me is the slope of the tangent line at that point is -1. So I'm going to go to that point and I'm going to draw myself just a little line through this point that looks like that, and that has a slope of -1. Then I'm going to take another point. So I'm going to take the point -2, +1. So now I'm looking at the point that's right underneath the one I just did. And if I plug that into my differential equation, I'd have -2 over +1, which is -2. So at that point, the slope of my tangent line, or the slope of the curve, is -2. So I want to draw a teeny little tangent line that has a slope of -2. You'll notice it has a steeper negative slope than the one above it because the one above it was -1. And what I tend to do is I like to use the points that are near it to help myself make an actual slope of -2. So for example, if I had a slope of -2, I'd be going to this point right here. And so I kind of imagine myself drawing a line between those 2 points, but I just put it on the one where I need to. So -2, +1 has a slope of -2. I know it's a little confusing. I can show you all when we are back in class. So let's keep going. I'm going to take the point -2, -1. If I plug that into my differential equation, that's going to give me a slope of +2. And then -2, -2 is going to give me a slope of +1. So I can go ahead and draw those into my curve as well. So let's see, -2, -1. I need a slope of 2. So that's going to be something like this. And then I need a slope of +1. So that's going to be something like that. Now I've done all of those points that are over there on the left. So I'm going to go ahead and pick an x value of -1. So I'm going to do -1 and +2. That's going to give me a slope of -1/2. -1, 1 is going to give me a slope of -1. -1, -1 gives me a slope of +1. -1, -2 gives me a slope of +1/2. So you'll see I'm kind of doing this in sets of 4. I'm doing these 4, I'm going to grab a different color here for a second. Doing these 4 points all at once. I put them all in my table, found my slopes, and now I'm going to just sketch my little line segments that go for each of them. So -1, 2 has a slope of -1/2. So that's going to be something like this. And then let's see, -1, So that would be like that. +1 and +1/2. There we go. For our next set of lines, let's see, we've got the point 0, 2. That's going to give me a slope of 0, and 0, 1. That's also going to give me a slope of 0, which means right here and right here I have horizontal tangent lines. So I'm just going to draw those straight across. I'm going to make myself another table here to keep track of my points. And let's see, I'm going to do an x value of 1. So I'm going to do the point 1, 2, 1, 1, 1, -1, and 1, -2. I'm going to find the slope at each of those. So that would be 1/2, 1, -1, and -1/2. And I'll go ahead and draw each of those points. So that's all of these points here that I'm circling. These 4 slopes are going to go on those lines there, those points there, excuse me. So let's see, 1/2 is going to be something like this. +1 is going to be more like that. -1 and -1/2 is going to go right about there. Maybe it needs to be a little bit steeper than that. Or less steep, excuse me. There we go. And then finally, we're going to do x values of 2. So we're going to do the point 2, 2, 2, 1, 2, -1, and 2, -2. So let's see, that would be 1, 2, -2, and -1. So these points here, or these slopes, are going to go on these points here on the right side of our graph. So we have a slope of 1, we have a slope of 2, and then a slope of -2, and a slope of -1. So you'll see all we have right now are just a bunch of line segments that we've drawn with different slopes based on what we found by plugging points into our differential equation. Now, the cool thing about this is we can sketch a solution for the graph given any point. So you'll notice down here, question 2, we're asked to sketch the graph of the solution that goes through the point f of 0 equals 1. So the first thing I'm going to do is I'm going to go to my graph, I'm going to plot a point at 0, 1. And we can see here all the different tangent lines for this curve. Now we should notice that at the point 0, 1, the slope of the tangent line is 0. And so because of that, we know that it's either going to be a minimum or a maximum, or I guess it could be neither. But if we take a look here, we can see that going to the left from the point 0, 1, those slopes are negative, and going to the right, those slopes are positive, which means the function changed from decreasing to increasing at the point 0, 1. Because of that, we know that this is a minimum. So we're going to just start at the point 0, 1 and sketch something that follows the slopes that we drew. It doesn't need to be exact, but we can see it's going to be something along those lines. So this portion of it kind of looks like a parabola. Our graph would look different if we had a different point that we were trying to go through. So it depends on the point that we're looking at and what the slope field actually looks like, but here's an idea of what it could look like. So I will see you all back in class for some practice and to kind of help solidify some of the things that you saw here. As always, if you had any questions, please make sure that you wrote them down. I will see you soon. Thanks for watching.